In this activity, we'll be creating a program that utilizes lifetimes with structures. Once you're ready, open up Visual Studio Code and we'll get started. Once Visual Studio Code loads, navigate to your Activities directory. We are on Activity 32, so scroll down to A32, double-click. Once the activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. Alright, let's get started. This activity topic is lifetimes and structures. Our requirements are to display just the names and titles of persons from the mockdata.csv file. The names and titles must be stored in a struct separately from the mock data for potential later usage. None of the mock data may be duplicated in memory. We have some notes here. The mock data has already been loaded with the include stir macro, so all functionality must be implemented using references or borrows. If we take a look at the existing code, we see we have a constant here, and it's just named mock data, and the data type is a borrowed stir. The tick static just indicates that the data lives as long as the program is running, so it could be accessed at any point in the program. This activity requires some external data, specifically the mockdata.csv file. So I'm going to load that now. The mock data file can be loaded by scrolling down to the bottom of your activities and double-clicking on mockdata.csv. So if we take a look at this file, we'll see that it's a CSV file, which is comma-separated values. So each field here is separated by commas. We only want, according to the instructions, the names and titles. So if we take a look at the CSV, the names are first name and the titles here at the end. So this is field 0, 1, 2, 3, and 4. So we're going to be working with fields 1 and fields 4. Before we actually store any data in the structures, what we can do is create the functionality needed to actually extract the information we're interested in. Once we do that, then we can worry about storing it into structures. So let's do that first. So I'll create a new variable. I'll just name it data. We'll take the mock data, and then we'll split it on new lines. And then we'll skip the first element. When we call .split, we're going to get an iterator over every single split of the data. Since we're splitting on a new line, we're going to get every single one of these lines as part of an iterator. So we'll start with this first one here. Then we'll get ID 1, 2, 3, all the way down to the bottom. We're going to call .skip on the iterator, and .skip is just going to skip this number of elements indicated. We're only interested in the actual data here, and we don't want this first line. That's why we're going to skip that one. The next thing we're going to do is just collect it into a new vector. What we can do now is grab the names out of each line. So we'll create a new variable named names, and we'll iterate over the data. We'll then call a filter map function on each line. Remember, when we created the data here, we're splitting on the new line. So when we iterate on the data, we're iterating over every single line, except for that first line because we skipped it. The filter map function will both filter and map some information. So what's going to happen is it'll filter out options. If there are none, they get removed. And if there's some, it keeps it. Everything it keeps is going to get mapped. And so it will change it from one thing to another thing. So what we'll do is we'll take the line and we'll split it into components, and the delimiter will be the comma. We'll then call the nth function on the iterator returned by the split function, and we'll take the number 1 index. If we take a look at our mock data, we'll see that the ID, that's going to be index 0, and the first name will be index 1. So that's what we're doing with the .nth function. We're taking that number 1 index. Finally, we're going to collect it into a new vector. Before continuing, I'm going to iterate over the names and print them out just to make sure I selected the right field. So we'll iterate over the names. We'll just take the first 3 because we don't need to see all of them. And then we'll print it out and see what we get. I'll test out the program by going to Terminal, New Terminal. We're on activity 32, so we can do cargo run --bin A32. So it looks like we have an error. It's indicating that we have to have type annotations. We're trying to collect into some kind of collection, but we haven't specified the collection. And we don't have any functions with signatures that specify what it is. So we need to use type annotations on the variable itself in order to let Rust know the type of collection that we want. So let's hop back to the code and we'll add the type annotations real quick. So we want to collect into a vector, and we don't care what type it is, and Rust can just figure it out on its own. We'll do the same for names, because names is going to be a vector as well. If we hop back to a terminal, we can try again. And so we see we get the first three names, Teresita, Perry, and Sadella. Let's check our mock data to make sure that's good. So our first names are here in red. So we have Teresita, Perry, and Sadella. So the names check out. The next thing I'm going to do is get the titles. So we'll get rid of this loop because we know we're good. And then we'll copy this and name this one titles. Now, if we look back at our mock data, we'll look at the titles are at the end. So we have 0, 1, 2, 3, and 4. So we want to select field 4. So we'll change this to a 4, and we should get the titles. I'm not going to test that one since we just counted it, and it should be fine. So we're able to collect the information we need and store it into a vector, and we're able to print it out. But the requirements indicate that we need to actually store these into a structure for later usage. So now that's where the lifetimes will come in. So I'll create a name structure. And we'll have an inner vector. It's going to be borrowed strings. And we'll also have a title structure. So I'll have two separate structures for my information. You could store them both in a single structure, but I'm just going to use two. Now, if we try compiling this, we're going to get an error about lifetimes. Let's just try it and see what it says. And it says we're missing a lifetime specifier. And it says right here, we need to have a lifetime parameter. And it also gives us some syntax and tells us exactly what we need to do in order to use lifetime parameter. So let's hop back to the code and just do what it says. So we'll add a lifetime parameter here, and we'll add one here. And we'll utilize it there, and we'll utilize it right there. So now if we go back to run it, we should get a successful compilation. Now that we've created our structures and it compiled successfully, we need to actually store the data within the structures. Because right now we just have them saved as variables. Let's do that now. So we'll create another variable named names. This will shadow the existing one. And we'll create a name structure with the inner value of names. And we'll do the same for the titles. So now we're storing this existing vector into the name structure by setting it to the inner value right there. And the same is being done here with the titles. The next thing we need to do is print out the information. I actually have two separate iterators. So what we can do is zip them together in order to iterate over both at the same time. To do that, we'll create a new variable. Let's call it data. We'll start with the names iterator. We'll grab the inner value, iterate over it, and we'll call the zip function. And then we'll take the titles, get the inner value, and iterate over those as well. So what the zip function does is it takes two iterators and it zips them up into a tuple, with the first iterator being field 0 and the second being field 1. So we're going to take the names iterator, the titles iterator, they're going to get zipped together, and we'll have a tuple with both the names and the titles, so it'll be easy to print out. So let's now iterate over the zip data. So we have name, title, because remember it zips into a tuple. So for each one, we're going to print it out. We have name and title. Name, title. I'm also just going to take the first 5 on the list because I don't want to flood the terminal with all of the names. If we hop back to the terminal, we can try running the program and ensure that we get the correct information. So here we have a listing of 5 names and titles. Let's just double check these to make sure that they're in the correct order. So we'll look at number 2 for Perry, and Perry is a junior executive. So I'll hop back to the CSV file, and we can see that Perry is a junior executive. So it looks like we're all done with the program. Before wrapping up, I just want to take a quick look at the lifetimes again. So if we look at these structures, we have our lifetime annotations here and here. The lifetime annotations are just indicating to Rust that this data right here exists somewhere else outside of these structures. And we know it does because it exists right here as a constant that's accessible everywhere. So whenever you have lifetime annotations, the data has to exist before this structure. The data is created right here, and the structure is created later in the program here. So everything checks out, and we can use the borrowed data. This concludes the activity on lifetimes and structures. I'll see you in the next presentation.